All right. I think it's about time to get this thing started. Good morning, good evening, good afternoon, everyone. Number of different people joining us from all over the world. Really appreciate everyone taking the time to join in and listen to the Bugsnag webinar concerning error monitoring at Zynga from development to production. I'm Eric Degler. I'm a customer success manager here at Bugsnag, and really looking forward to getting things kicked off. Before we get started, I'd like to remind you all to take advantage of the sidebar where you can ask questions and chat with the group. Please ensure that you set your recipients to all panelists and attendees so that I can, as a panelist, can see what you post, and also a number of the other Bugsnag moderators can also see what you post. This webinar will be recorded and made available after today on the Bugsnag website. We'll also send you an email, so be on the lookout for that. Let's get started. Bugsnag is a full-stack error monitoring and stability management solution recognized for our best-in-class support of mobile applications. We process 1 billion crash reports per day for applications worldwide across 5,000 industries. We have a number of important customers, but companies like Slack, Pinterest, Square, Pandora, and obviously Zynga ultimately use Bugsnag as their daily dashboard. As the trusted solution for error monitoring across multiple industries, we're able to observe shifts in the economy and particularly how they impact user sessions across various applications. These are certainly uncertain times in the midst of COVID-19. There are, of course, certain industries that are negatively impacted by the current circumstances, while others seem to carry on with business as usual. And meanwhile, there are others that even seem to be thriving. One such example of this is the mobile gaming industry. In April 2020, 40% of mobile app users reported playing mobile games more frequently. Verizon also reported a 75% increase in gaming app usage. Also, in just 1 week, 858 mobile games were downloaded worldwide. Now, this is on top of an already successful and extremely successful industry. One of the most popular mobile games in the world is the Hit It Rich casino game by Zynga. It boasts over 4.5-star ratings across the Google Play Store and the App Store with over 500,000 reviews. At a time when mobile gaming has skyrocketed, the Hit It Rich team has a tried and true method for error monitoring that helps maintain such a positive gamer experience. And very relevant to this conversation is our presenter, who's Leo Schnee. He's a software engineering manager of the Hit It Rich team at Zynga. So I'll let him go ahead and introduce himself.
Hey, everybody. Hopefully you guys can hear me. Perfect. All right. Hi, I'm Leo. I'm an engineering manager at Zynga, originally from Texas, graduated from the University of Texas. Hook 'em if we got any Longhorns on the line. I've been at Zynga for almost 7 years now. Man, time really flies. Since I've been at Zynga, I've worked on a handful of different titles, but most of my tenure has been spent on our casino match org, specifically on Hit It Rich, which is it's a casino game. We do a lot of slot machines, and just kind of a fun thing. We're gonna try and do a poll, try and use some of Zoom's functionality here. Tell you guys 2 truths and a lie about myself. So feel free to answer on the poll, submit it, and then we'll see how close everybody is. So A, I can snowboard double black diamonds. B, I've seen lightning strike a tree. And C, I can ride a horse bareback. So we'll give you a couple of seconds, kind of fill in some of this fun stuff, and then we'll jump into the meat of the presentation. So you guys are definitely correct. So I cannot ride a horse bareback. I can't even ride a horse regular back. So yeah, I've started snowboarding about 5 years ago, and I can do double black diamonds now. And when I was in high school, I was walking on a trail and lightning struck a tree about 20-30 feet away from me and exploded. So with that, let's kind of jump into the presentation, kind of what we're going to be talking about today. So whenever you're looking for any sort of an issue, there's going to be 3 main steps to it. You're going to need to identify what the issue is, you're going to need to prioritize and fix the issue, and then you're going to need to monitor the fix and make sure that you didn't introduce any new issues or anything like that. So with that, let's kind of jump into how we on Hit It Rich identify an issue. So the first thing about issues is there's two main types of issues. You have your release issues. Those are going to be anything that's tied directly to the release of your app. And then you have live ops issues, which is stuff that's going to happen outside of the normal release cadence that you guys are doing. So a live ops issue, like I said, anything that's going to be happening, or a release issue is anything that's happening on like a staged release. And then live ops issues is going to be your payments outages going out, an A/B test, maybe people in the B variant are crashing on the game, any sort of third-party services go down, or your servers crash, or anything like that. So how many people on the line have, and use the little raise your hand feature, have had a live ops issue that they've needed to investigate? Wow, you guys are so good with technology. Looks like you've figured out how to raise your hands. I couldn't figure it out. It seems like we got a fair number of people who have investigated live ops issues. We'll get to live ops issues at the end of the presentation. We're actually going to start with release issues and how we handle our release process, and then how we use that same process for live ops. So in order to understand how we handle our release issues, I think it's important to understand what our release process is. So for us, we basically have a server and a client. Our game is server authoritative. We have pretty much at any given time one live version of the server. There's a gradual switch over, but it's pretty quick. We try and keep only a single version living, but for clients, we have lots and lots of different versions just by nature of how the App Store works. So for Android, there's a couple of different options that you can use, but for us, we have the Canary option, which is basically doing a staged rollout on Android where you can specify what % you want and change it however you want over time. For iOS, there's an App Store rollout, which is basically the same thing, except for Apple controls that you don't have direct control over the rollout pace. And then we're a Unity game, so our Facebook platform actually is WebGL. And for that, we actually do an A/B switch similar. So there's a couple of different approaches you can use. The faster you can get users in, the faster you can get data. For us, we go with a more cautious approach, and we do a Canary process. And we found Android works the best for us. So we'll do like 5% of our users on Android, and then we'll see sort of what issues are arising, fix those, and then go in. But what are we monitoring in all of these releases that we have? So there's there's a lot of different things that we monitor. So we've got to keep track of, what our users are doing. Are they still playing the game? Are they able to log in? Are they experiencing any sort of errors and crashes? Are they getting more or less sessions? Is anything new that's specific to this release? Is the economy working for the game? Be that the coins in the game or purchases for the game. Are the frame rates staying consistent, increasing, decreasing? Are load times increasing, decreasing? All this stuff is really important to keep track of to make sure that your game is healthy. And for us, all of this information comes from a ton of different sources. So we have analytics keeping track of users and helping, and Bugsnag helping us with errors. We have payments keeping track of all our economy stuff. And then on top of everything, we have a bunch of logs that are just going into all of these different things. So I'm curious on the line, how many people have, how many tools do you guys use to manage the health of your apps? And so for us, we have a ton of different tools. So we're interested to see kind of what the spread is here. So we've got a couple of people, probably smaller teams using only, 1 or 2 tools. And then it seems like the majority of people are using, 3+ tools to keep track of everything that they're doing. So with that, I'm going to kind of talk about what our solution is for managing all of these tools, and then kind of how Bugsnag augments that. So for us, we actually take all of this information and we pipe it into Splunk. And I know what you guys are thinking. I thought this was supposed to be a Bugsnag presentation. I was going to be talking about Splunk, but it'll make sense as we kind of go into it. But we basically funnel all this information into a dashboard in Splunk, and then we'll build on that. So with that, I'm going to jump into kind of the live demo part of this presentation. It's possible this won't work. I have some other slides saved out if we have to click through, but I'm just going to kind of jump into the live demo part and show what we do when we're looking at the health of the app. So if we go into this Splunk view, I've kind of gone in and selected a time range to kind of give you an example. Normally we'd be looking at, recent information and not historical information. But this basically lets us look at a specific client type, compare versions to each other, pick different games to compare against, and then kind of bucketing stuff and filtering with Bugsnag. So like I was mentioning, we keep track of, how many users we have, how many app sessions we have, different sorts of crash rates by users or app sessions. We check to make sure players are spending stuff. We check to make sure that our FPS is matching where it's supposed to be. We're checking our memory usage inside of our machines and then everywhere else. And then we're keeping track of our load times, our device specific stats. Obviously, this is Android, so it's going to be pretty fragmented because the market is pretty fragmented. And then we keep track of our Bugsnag issues. So we have unhandled and handled issues in Bugsnag. And for us, an unhandled issue is basically anything that's an exception, either inside of Unity or a system level exception. So that would be like a seg fault or something like that. And then handled exceptions are anything else. So any sort of error logging that we're sending to Bugsnag to keep track of things. So some of you guys may have noticed when when I scroll down, if you're looking at this production crash rates, you can see that we have a spike on the latest release on this 9015 version. And it's good for a lot of graphs to go up and to the right. You don't want your error/crash graphs to be going up and to the right. So we've got an issue here. You can see some people have adopted it. We have like 1,000, 2,000 users playing on it, and we're still seeing a high crash rate. So there's a good chance that there's an issue with this release, especially since it spikes so high. So typically what we'll do is we'll go down and we'll look at these unhandled issues. And I've gone ahead and sorted these by release. And you can see we're keeping track of users and events. By keeping track of users and events separately, we're able to tell, is this one user getting caught into a loop that's putting them in a weird thing? We can also weigh more heavily on users that have potentially more VIP points or more total play time to kind of give us an idea of, which type of user is being affected the most. So for this particular example, we're going to take a look at this unhandled error that's affected 21 users and has 555 events, because it seems likely that that's where this spike is kind of coming from. So normally I can just click on this and it'll bring me directly into Bugsnag, where we can further diagnose the issue and kind of figure out what's happening. But if I do that, it's going to mess up the time search. So I've actually just opened it in another tab here. So I'm going to go ahead and click through to this tab. You can see we're looking at the same time period as we were looking at before. And here is kind of the Bugsnag view of what we're looking at when we're trying to find an issue. So you can see one of the first things I noticed is looking at this trend line up here in the top left. This issue just started occurring on the 11th, and today is the 12th in this example. So it's just spiking. It's specific to this release. As you can see down here, it's on 9015. It's only happening on our production Android stage. We can look at the stack trace here and see that, hey, this is probably happening because of this inbox list item rich pass, which I know is something that we just put into our game. So it's going to be something that's going to need to be fixed on this release before we release it. So now that we've kind of looked at that, we kind of have an idea of where the bug is coming from. We need to go ahead and kind of prioritize the issue and then get a fix for it. So normally when we're prioritizing the issue, we're going to be checking to see, hey, are these users affected? Can they still play the game? Are they getting blocked entirely? We'll send it to our QA team, see if they can get the issue to happen, if they can still play. And for this particular issue, we went through that process and we could see users were still able to spin the game even after this error/crash had happened to them. I would love to show you guys that data, but we don't store it for long enough to be able to historically go back and look at something, this far in the past. But you'll have to take my word for it that this is an error that was not causing users to immediately crash out. With that, now that we kind of have an idea of what's causing the problem, we want to assign this to somebody. And for us, we use Jira, and Bugsnag does a phenomenal job of integrating with any sort of bug tracking with a bunch of different services. So I believe it's this tab. Yeah. So you can see that there's a bunch of issue trackers that you can actually hook up in Bugsnag. Like I said, for us, we use Jira, but you can just see how many different sorts of issue trackers that Bugsnag will allow you to integrate with pretty seamlessly. And so for us, we have this issue. We'll just actually click this little exclamation point and it'll create an issue. This is the issue. This is the ticket that it created. I can go in and add a comment here and say like, hey, this is new in this release. And it'll add it to the ticket for me already. So if we go in and look at this ticket, you can see, we prioritized it as this is a bug. It's priority 1, needs to be fixed. We assigned it to our 6.10 release. Obviously, it's already been through our QA process and everything because we're looking at a historical bug here. But it does an amazing job of kind of keeping track of all of the error information that you could want to look at a glance, So you can see it has the stack trace. You can actually, click through on these links and view it in Bugsnag, view the full stack trace. It tells you who created the bug. And so here you can see we have assigned the bug out to Michael Murphy. He fixed the bug. It went through our QA process, and then QA was unable to get it to happen again. So now that we've done, kind of got the bug out there, got a fix, built it, submitted it back to our mobile submit team, it's gone back out. We're going to need to kind of monitor the fix that we have. And so how do we do that? It's largely the same process as we were doing here, where we were comparing releases, except for now we're going to compare these specific releases. So this is our old production release to our newest production release. So right off the bat, you can tell that our production crash rate has dropped significantly. So this is the old existing build that's kind of out in the wild still as people slowly adopt it. And you can see that our newest version 9036 actually has a lower error rate than our previous version. So it looks like we've fixed the issue. And we could go in and we could look down here and we could see this is kind of some of the ongoing issues that we have. We have a SIG7, a SIG abort that are kind of causing us problems that we're still looking into. But all this other stuff is like fairly low volume over the past week, considering that this build is ramped up to a high percentage of our audience. So with that, I'm going to kind of jump into another way you can kind of do this. If you want to see if a release is stable, you can actually look, there's a little tab here in Bugsnag for releases, and you can actually set a stability score for each of the releases. So the releases, we've done a couple small releases here and there, and some of these are like QA builds that we're testing on production. But our old build is 8944 right here. You can see it was at a 99.8% stability. And then we went to 15, and you can see it dropped. We actually did another build in between that, and we introduced a new issue that needed to be fixed. And then our most recent release here, which is starting to get adopted by everybody, is at a 99.88. So we're at a pretty high stability level here for the bugs that we're seeing. With that, let's kind of jump into our live ops issues. So if you remember, live ops issues were the issues that are going to be happening outside of your normal release process. So, anything that's going to be happening when you're potentially not at your computer. So Bugsnag lets you do sort of spike detection. Here's an example of like a spike that's happening on our production Android stage with unhandled errors. And this is really nice, but it's pretty much impossible for you to be staring at graphs for 24 hours a day, 7 days a week to try and find issues. So you need to have some way of alerting yourself. For us, when we're in the office, or I have a couple monitors here that I have up, we have an internal tool we call Zynga Operations, ZOps, where if there's any sort of an error, it'll tint itself red and it'll kind of bubble up to the top. So if there's any sort of problems, we'll be able to see it pretty easily. This integrates with PagerDuty for us, so we'll just get a message. You can click on it; it'll bring you to a wiki that has the playbook. Typically, the playbook, well, depending on the error, but if it's a client bug for us, it's it involves going into Bugsnag and figuring out what the issue is, and then the process is largely the same that you would have on a release bug. Identify it, make sure users can still play the game, and if it's a big enough issue, we may need to do either a server hotfix to try and mitigate the issue, or a client hotfix to try and force people off of a specific version of the game. And so for us here, we're using ultimately it's like boiling down to it goes into PagerDuty and then sends you a message. A lot of that can also be done inside Bugsnag. Like I said, for us, we're integrating multiple tools, so we needed to have a place to kind of put everything together. But if you were using Bugsnag just to monitor your errors and you weren't monitoring a bunch of other stuff, you can actually integrate right here with incident management, and you can configure PagerDuty or these other ones I'm not too familiar with, OpsGenie or VictorOps. But you can do that, and you can set up alerts based off historical changes or anything like that. With that, that's kind of a high level overview of how we go about setting up our monitoring in general. And I'm gonna hand it back over to Eric to see if he has any closing remarks.
Yeah, Leo, thank you so much for that. I think that was really informative. From my perspective, it was super interesting to see how errors kind of move through the process. But I would say at this point, I'm going to transition to kind of a Q&A. We have a few questions coming in from the audience. So I'm going to start off with the first one. When I was looking at your dashboard, noticed that you had like a 99.8% target for stability inside of Bugsnag. Just curious on how you arrived to that number. What sort of determined that sort of acceptable level of stability, and what do the colors sort of mean here? Sort of three different representations of stability on this screen.
Yeah, so if you notice, the numbers here don't necessarily match up with the numbers that we're seeing internally, and that's because in different places we track our error amounts differently. So what we say is an error here may not necessarily be counted as an error there. But for us, it's just historical data on what our stability has been, and we kind of set a benchmark from there to where we try and always be in the higher percentage of everything. And you can actually go in and you can click this button right here, and you can kind of see what the historical stability is, and maybe we have a dip here and that needs to be fixed. And yeah, so it's just kind of feeling it out, kind of figuring out what you want. And the colors in Bugsnag are just it's red is not good. It means you're getting closer or further away from your target stability. And then yellow is, kind of in the middle between that.
Yeah, no, that makes complete sense. One thing we also noticed was, I think there was a question coming in that said, were there any learned lessons from how errors are tracked in the code to provide the most value when they arise and it's time to debug and find them? Like, were there any lessons that you learned, sort of in setting this up, and also taking a look at the errors as they were coming in terms of debugging them and locating?
Yeah, so there's a bunch of different ways that errors can kind of manifest themselves. Obviously, if there's a stack trace for it, it's pretty easy to figure it out. You don't exactly have a line number, so having clear and concise functions on what is actually happening is super helpful for being like, okay, there's an error in here. I don't want to just null check everything to try and fix it. I need to find the root cause potentially. It's a lot easier if you know exactly what is causing the null reference exception and why it's happening. So the smaller your functions are, the easier that stuff's going to be. You can just throwing in a null check for a bug isn't necessarily going to be fixing the bug too. So it's something to consider when you're looking at bugs, is making sure that the fix that you're doing is actually a fix that makes sense to do. So it might be better to have, if the game has a catastrophic failure, like let's say there's, the login data didn't come down properly. Well, you can't actually play the game if the login data doesn't come down properly. So throwing in a null check isn't going to fix it. So you need to be kind of aware of kind of the whole code stack and what is going to be catastrophic if it isn't there. So being able to tell somebody is able to play the game after you fix a, or after a bug happens is a pretty good indicator that it wasn't a catastrophic failure. But definitely defensive coding and making sure that your variables are getting used properly and is a good call.
Yeah, no, that makes complete sense. Another question from the group was, how is China handled? With firewall restrictions, multiple stores, and they noticed that certain other products had issues because of Google services and not desire to have Google stuff in their code. So just curious about how you guys handle China as a region.
Our game is largely in North America and Europe. We don't have a ton of Chinese influence in our game, so it really hasn't been a problem for us specifically. It's certainly something to be aware of, but it hasn't been something that I can speak to specifically about.
Okay. One other question is, do you use Bugsnag for information logging also in addition to bug tracking? Is there like a place where you guys put in certain notes inside of Bugsnag itself, or does that live in another system?
Yeah, so Bugsnag is actually one of the areas that we put in some logs. So, well, like I was mentioning before, the handled exceptions are pretty much anything that isn't an exception that's getting logged into Bugsnag. And so we do sample that amount a little bit, but it's definitely a good place to put in logs for errors that you have that you want to investigate. Additionally, with every single bug that goes into Bugsnag, you can attach breadcrumbs to it. So you can actually put a breadcrumb into like the Bugsnag system without it actually creating an error. And then once an exception handled or unhandled happens, it'll attach the breadcrumbs and you'll be able to look through it. So like it's not going to be potentially might not be helpful for this particular example, but if we look, we have breadcrumbs here and it looks like, people are spinning a specific game, this like Gen 39 game. People are, here's a log error that's happening. So this is a breadcrumb that we put in manually, and this is an error that we have that's just getting logged into the breadcrumb system. And these breadcrumbs make sense because it's happening in our inbox when they're playing a gifted free spin. So it makes sense that those logs there make sense. But yeah, it's easy to use Bugsnag to kind of keep track of logs that are happening on production as well. But I would recommend that you sample them out so that you have a finer granularity on the really important bugs versus the potentially unimportant logs.
Yeah, no, that makes a lot of sense. And I appreciate that answer. There were some questions around the breadcrumbs coming in. So I hope that answered that person's question who asked about the breadcrumbs as well. One other question that we've gotten from a couple of different users is, what sort of purpose does Splunk provide if the information is already existing inside of Bugsnag already? Is there something missing there? Is there like a complementary function there? What's sort of the reason for using both?
It's really just augmenting it. So we keep track of our users in a couple of different ways. Bugsnag does a pretty good job of keeping track of sessions, but they don't keep track of users in the same way that we do. So we want to find out how many crashes we have per user. We dedupe our users differently than the service of Bugsnag does, just by the nature of everything. Additionally, like we don't see like FPS changes in Bugsnag because it's not keeping track of that. None of our payment information is going into Bugsnag. And our Bugsnag does keep track of memory, but it doesn't keep track of it in the granular way that we would necessarily want to do it. So there's more to the health of the app than just specifically, is it crashing? Majority of the time when you're looking at it, you're seeing, does it crash? But, if we load this up and we see the load times are, going from, 20 seconds here to, a minute and a half, like obviously there's a problem and that wouldn't necessarily have been caught in Bugsnag. So it's just nice to have that kind of holistic view that's putting in everything for us to be able to see what the issues are. But I would say like 90% of the time, maybe 95% of the time, we're going into Bugsnag once we realize that, hey, there's something that we want to fix for this.
Yeah, yeah. Another question that came in was, do you have experience dealing with native crashes, and how do you approach those particular types of crashes?
Yeah, native crashes are always fun, especially when they're in code that you're not in charge of. Like let's say like an ads engine or something like that you're running. Um, Obviously, if you have some sort of a relationship with the ads, the team that makes the ads, you can submit a thing and submit a pull request potentially and fix it. But we have seen a couple of native crashes, and I'm going to try and pull up one inside of Bugsnag if we can. So this SIG7 is a native crash that we're seeing that we're running into. And you can tell like some of this information is not necessarily helpful. And I think we're having an issue here where our like symbolication file isn't actually getting uploaded, which is an issue on our side. But we actually have this exact same issue happening on iOS where we are having the same problem. So this is like a system level crash because we're not really getting any information here when we normally should be. But if we look at the equivalent crash in iOS where we are doing the symbolication links correctly, you can see that we're actually getting a stack trace here, and it becomes a lot easier to like see what's happening. So Unity itself is dead before this happens. It's not having a good time, but we can actually see like, hey, this is what the problem is. We have a Stack Overflow here, and you guys are probably familiar with this. This like refresh is calling get, calling refresh, calling get, just infinitely basically. And that's what's causing our Stack Overflow and causing us to run into issues.
Yeah, yeah. Another question that came in was specific towards ANRs. How do you address ANRs in the application since they're slightly different and trickier than normal crashes?
Yeah, ANRs are definitely trickier. For us, we'll make builds and kind of how you saw, we're doing a bunch of other releases here, and some of that stuff is trying to resolve specific ANR issues. Bugsnag tracks ANRs, so you're able to like use Bugsnag to see if you have a spike in ANRs. But also like the Google Play Console is a good spot to look as well. There's different information in both of those, and basically when you're tracking down these weird edge case bugs, any sort of information is helpful. You're kind of grasping at straws sometimes and just kind of putting fixes out there and to 5% of your audience and hoping that you see a decrease in the crash.
Cool. No, that sounds good. One thing that you touched on in the presentation was the results, and you had kind of a nice little visualization inside Splunk around A/B testing. And just sort of curious about if you can elaborate more on how Bugsnag is able to give you more insight into errors that might be caused by those particular A/B tests.
Yeah, so a lot of that has to do with the way that you do live ops monitoring. So if you're doing an A/B test, you might want to have like a specific view for something that's happening, or like for a specific portion of your code that you want to look at. A lot of this live ops stuff is going to be, if you see a big spike in something, but if you're ramping something up to a small percent, 10% of people, you're not necessarily going to see a huge spike in anything. So you're going to need to have a bit more like fine grain tuning. And what you can actually do in Bugsnag is you can look at new errors that are happening. If you think it's going to be new errors, or just looking at trends and seeing, is there going to be a spike? And some of piping it into Splunk gives us a little bit more of that control, so we can, sample stuff and get like kind of a bigger or a smaller set, or look at specific users that we know are getting, whitelisted into a different sort of variant for the A/B testing.
Yeah. And I know you also highlighted the Jira integration a little bit as well. How is that transition process from taking like an issue in Bugsnag and sending it over to Jira? Is it just like a single click? Is it automated? Like, if you could touch on that in a little bit more detail as well.
It's so easy. like we've used other services before where it hasn't had a seamless integration, and you got your one tab that's got the Jira ticket that you're making. You're kind of transferring information over back and forth. But I might just actually be able to do, if we look at like the timeline view here, I'll just pick like some random error that doesn't have a thing here. So you can see these are the errors that actually already have stuff in them. Here's just a random error that we have. I can actually just click this button here, create a Jira ticket, and it'll allow me to create the Jira ticket. And I'll say, Bugsnag test or something like that. And it'll create the issue here. It creates the issue, and now it's linked up. So if you were in the other view, you could see it. If you just click this view linked issue, it'll bring you into your Jira process, and you can assign it out to anybody that you want. And it's got, the stack trace in it. You can click view on Bugsnag. It'll bring you back into the Bugsnag view of what the issue was. It shows you that I created it. And now it just goes through your normal sort of whatever the flow is that you use to track and fix bugs.
Yeah, no, thanks for highlighting that. I think it was good to kind of see the interoperability between the two platforms. Another question from the group was, do you mix information grabs from stores, such as the App Store, Play Store, Google Analytics, about new users in terms of app installation and removal? Like, is that something you guys do in order to keep track of all that information in one place?
That is definitely something that we keep track of. It doesn't necessarily happen in this particular client release health, but it does happen with like our analytics pipeline, where we're making sure that the app health, like people are still installing the game. We're not getting a mass exodus. Typically, that sort of a mass exodus isn't going to be from a release version that goes out, and if it is from a release version that goes out, you would see your unique users are dropping drastically. So you would have an idea like our total users are dropping, but like I said, we're doing a staged rollout, so things are pretty safe.
Yeah, no, that makes sense. One other question that was also coming across is, in terms of identifying and fixing issues for the Hit It Rich application, is it something that's always owned by your team, or do you have to rope in other teams as well? How does that sort of play into the, making sure the app is stable?
It really depends on the issue. At Zynga, we're pretty lucky. We have a lot of talent at Zynga, and if there's a sort of an issue that's super complicated, we can potentially pull in somebody from a different studio. And we've been pulled in from other studios when we've had similar issues to what they're experiencing. But I would say generally, each team is kind of figuring out their own issues, unless it comes from sort of a central service, or like ads or something like that.
Yeah. Do you also keep track of Apple reporting crashes? Do you guys go and look at Apple's sort of framework for reporting those crashes and kind of compare them between Bugsnag and Apple and Bugsnag and the Play?
I have not done that comparison. We don't actually. The majority of the people at Zynga don't have access to the Apple portal.
Okay. Well, I think we're hitting sort of the end, about the 45-minute mark of our presentation. Leo, hopefully me and the audience didn't grill you too aggressively on any of those questions, but I just want to thank you so much for the presentation. And since we don't have any more questions coming in, I think we're going to conclude the Q&A portion. Other than that, if you have any other questions, please reach out to hello@bugsnag.com. You can always reach out to us and get more information about Bugsnag or view the recording of the webinar afterwards. But thank you all very much for attending. Really appreciate your time, and enjoy the rest of your evening, morning, or afternoon.